Hey guys, we're moving right along with the Academic Chemistry Benchmark 1 tutorial videos. So this is the part 2 of day 1. Remember, this only works if you have questions. Definitely ask the teacher or the tutors that are in the area. So whenever you have questions, make sure you pause the video to ask, and pause it anytime if you just need to think about whatever it is that we're going over. So we talked last video about what are sig figs. Which digits are sig figs, but the point is, why do we care? So it matters when you're taking measurements. So if you see here, when you're recording a measurement, you're always going to include, and this is really, really, really important. So if there's anything you get from today, this should be one of the top things. Whenever you take a measurement, you have to list all of your known digits, and at the end, there's always one that you estimate. And by known digits, I mean the digits that are shown in the graduations. So if you look here, this is a bit of a graduated cylinder. So you can see the liquid's filling, and here's the meniscus is what makes that curve. And all of these lines are graduations. That's what you actually use to make your measurements. So like here I have 7, and here's 8. So I have all these ones between, so that means that's 7.1, 7.2, 7.3. That also means that this says 7, but it's not actually 7. Since this is 0.1, 0.2, 0.3, this is actually 7.0, which is very misleading for students. So the first step is kind of what I just went over. Determine how the graduations are changing. And I'm going to move my window there. So these are your known digits. So if we look over here, we've got, this is 6.1. This is 6.2. This is 6.3. I'm going to, for the duration of this video, put my known digits in a red box. So this we could say this graduated cylinder is calibrated to the 10th position because it's changing 0.1, 0.2, 0.3. That's your 10th position. After your decimal, you have your 10th, your 100th, then your 1000th. So since this is changing by the 10th, then your measurement needs to include the 10th because you know that for sure. And then you need to include the second step, which is determine the last graduation before what you're measuring. So you know how they change by, and then like right here is my meniscus, so this is the very last graduation that it passes. So I know I'm getting to that 6.6 milliliters. Now some might say it's right under. I think it goes right at it, but that's okay. We're getting pretty much exact. So you always want to write your last known measurement. For this, it's 6.6 milliliters. The third step is then to determine your estimated digit. So we already determined our known digits for this are 6.6 milliliters. The estimated digit should be one place to the right of the last digit in your known position. So remember, I had 6.6. That means you need 6.6 something that you estimate. So if your measured object lands directly on the graduation, your estimated digit should be a 0. If your measured digit does not land directly on the graduation, you have to estimate 1 to 9 somewhere after that graduation. So for this one, we've got 6.6 milliliters is my known. I know, see how it's blue right behind that graduation? Don't know why I got close, that's not going to help you see, but right here, it's right at that 6.6 mils. See how it's blue on the side? It's there. I know that. Does it go above or below? Obviously not below because it's hitting it. So how much above? Well, I don't think it's really going above at all. So I have to still include one estimated digit. Even though this is my known and I don't think it's going above that, I need to go to my 100th position if I'm calibrated to my 10th. So my real measurement is going to be 6.60. That tells other scientists that the instrument I used was calibrated to the 10th because I wrote something to the 100th. So how about this one? How big is this pen? Like how long is this pen? So we made it a little bigger down here to kind of see easily. So I'm going between 4 and 5, and I measured between 4 and 5 down here again. So the tip of the pen comes right here. So what's my last known graduation? Well, this is the last known graduation. And what is that? Well, this is 4 and this is 5, and I've got 9 marks between that. 4.1, 4.2, 4.3, 4.4, 4.5, 4.6. This is 4.7. I can't just write 4.7. I have to give one more digit. So where does this land between 4.7 and 4.8? So I'm dividing this almost in my head into tenths, but I'm estimating it. It's completely estimated. There's something to tell you if that's for sure or not. So like a 4.72 or a 4.73 centimeters would be an appropriate measurement for this. Notice that these as well change by my tenth, so my measurement has to go to the hundredth. You always have to go one digit past your graduations. All right, so now it's your turn. You've got 3 different things you're measuring here. So I'm going to give you some instructions and then I want you to pause the video and answer these on your own. So you've got this graduated cylinder. You have to figure out the volume. So where does this land? Here's a scale, which we don't really use too much now that we have a bunch of electric balances, but notice it goes biggest to smallest quantity, so you have to read all 3 marks, and then here's the smallest so you can make your estimated digit here. And then here's a ruler showing centimeters. I want you to tell me how long is this paper clip. So go ahead and pause the video, and as soon as you're done answering these 3, we'll hit play and we'll go over the answers. Okay, so you should have answered the 3 questions now, so let's talk about what the answers are and why those are the answers. Starting with the graduated cylinder, the last graduation I see, my last known digit is 110 milliliters. See how this is 100, and that's 50, and I have 4 spots between them, so that's 110, 120, 130, 140. I know for sure that I have at least 110 milliliters. I have to estimate one more digit. Notice it doesn't get to 120, right? So 110, this 1 and this 1, those 2 digits, I know for sure. This 0 is not significant. I haven't said it's included yet. So that's where I'm estimating. Any of these would be appropriate measurements. 113 milliliters, 112 milliliters, 114 milliliters. All of those would be fine because you're estimating, and it's kind of hard to see when it's, that. Earlier I said 113, I'm kind of thinking 114 now, but any of these are fine because you're estimating that last digit and they're all pretty darn close. So let's go over here to the scale. You've got 50 grams, you have 9 grams, 0.4, 0.5, it's somewhere in between. So this is 59.45, and then you've got between that. So your known stuff is 59.45. Notice you don't get to 59.5. That would be over here. So your graduations are going to the 100th position, because this is the 10th, and then there's 9 spots in between each. So these graduations are going to the 100th. So you have to go to the 1000th, which is really hard to see in this for me, but it's an estimation. So one of these might work, 59.450 or 59.451. It's really, that arrow is hitting right after that 0.45 marker. So it's got to be somewhere around there. For this paper clip, it was really hard for me to see, and sometimes you might want to do this. I did a line right after it. So I know I'm going to look right before that line starts. So how are these changing? Where here's my 4 centimeters, my 5 centimeters, and I've got 9 spots between them. So this really isn't 4, remember, this is 4.0, 4.1, 4.2. I don't quite get to 4.2. I know this is at least 4.1 centimeters, and then I have to estimate how much between 4.1 and 4.2. So like a 4.18 centimeters and a 4.19 centimeters would be a good measurement for how long this paper clip is. All right, so what's the big deal? What's the difference between 85, 85.0, and 85.00 centimeters? And I just used this random number, 85, and then added some zeros to talk about it. Well, look at this ruler, and I just took the middle section of the ruler. If I was measuring something and it ended here, now obviously there's stuff happening here because you don't just start a ruler in the 80s, but if it ends here, you gotta think, which measurement would match what's shown? Well, I've got 80 marked, 85, 90. In between, I've got marks. So this is 81, 82, 83, 84, 85. I'm changing by the ones. So which of these measurements matches? The thing about science is when you take a measurement, someone else needs to be able to replicate all of your experiment for peer review so that we know what you've done really, really works, which also includes how precise did you measure things? Because maybe because of your precision, you might have gotten a better answer or a wrong answer because you weren't precise enough, and you need to explain to other scientists exactly what instrument you used, not only your measurement, but how precise was your instrument. So if I was using this ruler and it changes by the ones, I can't have my number end with my ones. I also can't have two spots after my ones because you only get to estimate one digit. So this 85.0 is the only measurement of these three that could ever come from this ruler. Remember, your last digit is always estimated. So that tells you how precise your instrument is based on the last digit. How small did you have to estimate? Like how big was your guess in your measurement? So in the following, we're going to identify which digit was estimated in the measurement. So I want you to pause the video and figure out what's the last significant digit in all of these measurements, because that's what was estimated in this value. So pause the video, and when you come back, we'll go over the answers. Okay, so for the first one, we have 4.3 centimeters. What's our last sig fig? Well, this 3 is the last sig fig. So that must have been the one that the scientists estimated. That was the one that was like, it probably is that, but it might not be the 3. I know my 4 is for sure. My 3 is probably. In this one, 83.004, the 4 is estimating, meaning the scientist was like, it looks like a 4, but maybe it's not. This 0 is for sure. This 0 is for sure, and definitely the 8 and the 3 are for sure in our measurement. 1.00, the last 0 is estimated. In 1.08 times 10 to the 13th, remember everything in the coefficient is a sig fig, and it's always the last sig fig is your estimated value. So if I look at 1.08, the last sig fig is an 8. That's what was estimated. All right, so if the last digit is estimated, then the digit before that is where the smallest graduations were. So remember when we had this 85.0 centimeters, my 0 here was my estimated digit because it's the last sig fig, which means that the 5 was where I had my last calibration or my last graduation here. And notice I have a graduation there at the 5. So in the following, you're going to tell me which one of the digits was the last graduation mark, or how are the graduations changing. So in each of these, first figure out where the estimated digit is. And remember, the digit right before that, that's where your calibrations are changing, or your graduation marks, you're going to see them. Okay, so freeze the video, and when we come back, we'll go over the answers. All right, so for 4.3 centimeters, your 3 is estimated. I'm circling estimated in red like I did before. So in 83.004, the 4 is estimated, and 1.00, the O is estimated, and 1.08 times 10 to the 13th, the 8 is estimated. This is what we figured out before. The last digit was estimated. Now I want to know how the graduations are changing. In my 4.3 centimeters, if this is estimated, my graduations are changing in the units position, in the 4, the spot before the estimation. And here, 83.004, the 4 is estimated, meaning this last 0, that's where my graduations change. 1.00, last 0 is estimated, the 0 before it, this is where my graduations are changing, meaning in this one, every 10th position, there's a new graduation on my scale. Well, it's a scale because it's kilograms. And for this one, I'm estimating that there is this 8 number of atoms, so the 0, I know that for sure. All right, in the following exercise, I've made a few graphics and a few measurements for you to do. So I've got these 4 measurements, and notice they're all pretty darn similar. I've got 8.20 centimeters, 8.2 centimeters, 8 centimeters, and 8.204 centimeters. And here I have 4 rulers. Now these rulers aren't to scale, so I don't want you thinking about like why it suddenly gets bigger or smaller. I just tried to make it easier for all to see. What I want you to do is I want you to play matching. Which of these measurements would match which ruler and why? Think about what you know about the estimated digit and how the graduations are changing based on that estimated digit. So go ahead and freeze the video, and then when we come back, we'll go over the answers. Okay, so you should have answered these 4 matching questions. So in 8.20, I know that my 0 is estimated, so my 2 is for sure. I need my graduations to change in the 10th position here. This is changing in the 1s. This is changing by 10s. This is changing in the 10ths. So 8.1, 8.2, 8.3. So since this goes to the 100th, I must be measuring at something that changes by the 10th. 8.2, 2 is estimated, so 8, my unit position, is my last known position. We already went over this ruler changes by the units, so those match up. In my 8, this is kind of a weird one. So my only digit that I have is actually also my estimated digit. I don't have any known digits because I didn't get to any graduations for this ruler. So I need a graduation that's bigger than what you even see or what's measured. So that would match this ruler here. 8.2004. So my 4 is estimated. So my 0 is known. So 10th, 100th, 1000th. If my estimated digit is in my 1000th, then my known digit, my graduations, need to be changed by my 100th. This is the only one left, but it also is changing by 100th. This is 8.2, 8.3. I've got 9 spots between them, so this is 8.21, 8.23, 8.24. So this is here. So this measurement would be about maybe like right here is where it's hitting on the ruler. All right, so if you have any questions about this, make sure you raise your hand and talk to whoever is tutoring in before school or after school right now, and I'll see you in the next video. Thanks.